The goal of this project is to estimate the pose of a quadrotor using a deep neural network based solely off of camera images. So this video shows a quadrotor flying around an indoor flight arena, and so the idea is that we'll try to track this quadrotor using only the images of the video. To do this, we'll use a pose estimation neural network. So the concept is shown here. We have an image of a quadrotor on the left, which gets fed through a convolutional neural network, which outputs a pose estimate, which can be represented by position XYZ and rotation matrix R. So to train any neural network, you need a lot of training data. And so to generate training data for our network, we use a 3D model of the quadrotor. So we generate 100,000 renderings of the model at random poses and superimpose each rendering on top of a random background image. So that gives us a bunch of images with which we can use to train the network. And then once the network is trained, we can implement it on the video that we showed at the beginning. So the results are shown here. The red represents the neural network estimate of the quadrotor. And we can see that the neural network does a generally decent job of tracking the quadrotor, but it's definitely not perfect, and the estimates jump around quite a bit. And this video in particular is difficult to estimate because the quadrotor is black and there's a lot of black in the background of the video. Additionally, the quadrotor has symmetries which make it difficult to exactly estimate the orientation of the vehicle. In that experiment, we used an ultrasonic beacon to measure the ground truth position of the quadrotor. We were unable to measure the ground truth orientation, so this plot just shows the translational error. We can see that the neural network estimate of position generally follows the true position, but it's definitely not perfect. So in summary, using a neural network to estimate the pose of a quadrotor is a promising idea, but there's still room for improvement.